Question 8. What total amount of energy in calories would be required to shift all the electrons from the first Bohr orbit to the sixth Bohr orbit in 1 mole of hydrogen? Through what distance would each electron have to move? What frequency of radiation would be emitted if the electrons returned to their initial state? We have to find out the energy in calories. Electrons will shift from first Bohr's orbit to the sixth Bohr's orbit, and this is for 1 mole of hydrogen. 1 mole of hydrogen means it will contain Avogadro number of hydrogens, that is 6.022 into 10 to the power 23 hydrogen atoms. 1 electron volt is equal to 1.602 into 10 to the power minus 19 joules. Now when the electron goes from the first to the sixth orbit, it absorbs a certain amount of energy. Now delta E will be equal to energy. So energy in the first orbit minus energy in the sixth orbit. The formula for energy is minus 13.6 divided by n square. This is for hydrogen, for which the atomic number is 1. So E1 will be equal to minus 13.6 divided by 1 square, and E6 will be equal to minus 13.6 divided by 6 square. And difference can be written as minus 13.6. We can take minus 13.6 as common and we get this equation 1 by n1 square minus 1 by n6 square. Putting the values of n1 and n6, value of delta E will be equal to minus 13.6 into 1 by 1 square. This is for the first orbit, minus 1 by 6 square, with this is for the sixth orbit. Solving, this is equal to minus 13.22 electron volts. Now this is in electron volts, so first of all we will change it into joules. तो joules में change करने के लिए we will multiply it by 1.602 into 10 to the power minus 19. So the value of energy in joules will be minus 13.22 into 1.602 into 10 to the power minus 19. Now this energy is the energy of electron in one hydrogen atom, and atomic number of hydrogen is 1. So every hydrogen atom contains 1 electron. Now multiplying this with 6.022 into 10 to the power 23 will give the energy of electrons of 1 mole of hydrogen atoms. But this value is in joules per mole. So we will divide it by 4.2 and we get the value of energy in calories per mole, which is equal to minus 30.37 into 10 to the power 4 calories per mole. So the energy which has to be supplied or which will be required to shift the electrons from first to the sixth Bohr's orbit will be equal to plus 30.37 into 10 to the power 4 calories per mole. Now another question is, through what distance would each electron have to move? Now when an electron is going from the first orbit to sixth orbit, we will just subtract the radius of the first orbit from the radius of the sixth orbit. Now the formula for radius of any nth orbit is equal to Rn is equal to n square into R1. So the value of R6 will be equal to n6 square R1, where n6 is the sixth orbit, and the value of R1 will be equal to n1 square into R1. n1 is the first orbit, और दोनों का difference ले लेंगे तो we will get delta R, that is the distance that each electron will have to move. Taking R1 common, we get R1 into n6 square minus n1 square. Now value of R1 is 0.529 angstrom. n6 square means 6 square, n1 square means 1 square. Putting the values and solving, the value of delta R is equal to 18.515 angstrom. Now another question is, what frequency of radiation will be emitted if the electrons returned to their initial state? तो इसके लिए जब electrons sixth orbit से first orbit में वापस आएंगे, then we have to find out the frequency of radiation emitted. So delta E will be equal to E6 minus E1. Now energy of electron in any nth orbit, the formula can be written as minus z square b divided by n square, and this is the energy in joules. अब B एक कांस्टेंट है एंड इट्स वैल्यू इज 2.18 into 10 to the power minus 18 जूल. Z की वैल्यू हो जाएगी 1 बिकॉज दिस इज हाइड्रोजन एटम और N की वैल्यू डिपेंड करेगी इन विच ऑर्बिट द इलेक्ट्रॉन इज. तो for sixth orbit the value of N will be 6 and for the first orbit the value of N will be 1. So E6 minus E1 will be equal to E6 की वैल्यू हो जाएगी minus 2.18 into 10 to the power minus 18 divided by 6 square that is 36 minus E1 की वैल्यू हो जाएगी minus 2.18 into 10 to the power minus 18 divided by 1 square which is 1. सॉल्व करेंगे वैल्यू आ जाएगी डेल्टा ई की 2.1195 into 10 to the power minus 18 joules. Now value of delta E is equal to h into frequency. H is the Planck's constant. So frequency will be equal to delta E divided by Planck's constant. Putting the values of delta E and Planck's constant, the value of frequency will be equal to 3.198 into 10 to the power 15 hertz.